In the previous series of videos, we've seen multiple examples of C++ standard library container objects, such as vector. But we want more, and we want to be able to not just use member functions built into these containers, which could provide a lot of different types of functionality that may be very useful, but at the same time we want uniform algorithms to be applied on sequences of elements, on the elements stored in our container. So we want to be able to find, remove, sort them, and other types of operations. So in this tutorial we'll switch back to this series of animations, and we have a section right here that animates a number of algorithms. So let's take a look. An algorithm named count. Okay, remember, every algorithm in C++ standard library is a function that is expecting some iterators to be used. So in this sample, we pass a vector of strings by reference to a function named f, and here we start calling the count algorithm, which basically says let's start with the beginning and ending of this container, and we're trying to locate a specific value. So this returns back the counter is set to 2 because you can see that there are 2 entries in this vector that contain this string. So count is a very popular algorithm. You can imagine you can specify certain ranges of elements in your containers, and it'll work with all C++ standard library containers that support a sequence of elements. Another example, copy. So copy is very standard procedure, and many things can be done with the simple assignment of one, for example, vector to another. But if we have to use a range of values, then we can use a copy algorithm. So once again, we pass the same vector example as by reference into a function, and there we take its size, right, and we construct a copy. And notice that to use a copy algorithm, you have to allocate, you have to reserve a space for the target elements. So here we say copy from the beginning to the ending, and we begin copying from the beginning of our from the beginning of our vector right here, right? But the target of copy starts right here. So basically, when we execute this algorithm, it starts at the top and goes to the top, and then just cycles through all of these assignments, and one by one you can see what happens. And by the way, the straight lines that you see in this animation are all examples of iterator objects. Okay, so internally the copy algorithm, if I try to rerun it for you right here, this animation, when you see these lines, the straight lines, these lines actually are painted by the iterators that copy creates during its execution. And so as a result, when it's done and we exit out of this function, you see that now we have we just populated a local copy of this original vector. Now another example would be a reverse copy. So reverse copy is just very similar to the copy, but of course it's using from the beginning to the ending, and also specifying the beginning of the target vector, and also has to reserve, you have to reserve the space, but it's not very challenging because you already know the size of the source, how many elements are there. And when we reverse copy, it basically starts from the end and goes in reverse direction. And once again, the straight lines are actually copies of iterator objects that are created and used by this algorithm at runtime. And you see when it's done, the lines are gone, which means that these temporary iterators are actually destroyed. They're no longer needed. And on the next line, as we move on, I see that now the content of this vector is reversed. Another example of an algorithm could be a replace. Okay, so here once again we start with this familiar riddle, and then replace takes the element value and the value to replace it with. So right here we're trying to replace sea with ocean. So here this replace algorithm once again just finds locations of the sea here and replaces them in place with an ocean. And so once it's done, you see that the result is obvious, that we replaced the requested values. Another thing you can do is to reverse. So this is an example of a reverse. So here the vector v is passed to our function by reference, so we get full read and write access to this container. So apparently this function is designed to really kind of reverse the order of elements there. So here you can see the animation that the reverse does. Of course, it just copies the values, exchanges the values, really just exchanges each corresponding pairs of values. And here it finishes somewhere in the middle of the container, and now it's done. So you can see, actually, because we're displaying these iterators in action during this animation, which animates the actual execution of the C++ code, you can see a little bit of an insight into how this specific algorithm is implemented and what it does. And earlier in our presentations, we looked at container demonstrations right here, and in some of these, like for instance list operations, we also saw examples of sort algorithm, because in the middle of this demonstration you will be able to observe how the sort of a vector of strings is executed in this specific sample right here.